Welcome to Module 3, Overview of Telecommunications Cabling. Once again, I'm Ted Chandler, your instructor in this online course on network cabling systems. In this module, you will learn to first discuss the golden rules of telecommunications cabling. Then you'll be able to name the different types of copper cable, including unshielded twisted pair, shielded twisted pair, and screen twisted pair. You'll also be able to identify other types of telecommunications cabling, including optical fiber, coax, and plenum. And finally, you will be able to discuss the basic construction and performance of copper and optical fiber cable. I'd like to set the stage for this module by reviewing the laws of networks. Recall from Module 1 that I presented several laws or golden rules of networking and telecommunications. So let's review them. First, that networks never get smaller. Plan for more users, more traffic, more capacity. Then networks never get slower. Plan for higher speeds, increased throughput, and reduced response time. And third, networks never stay the same. So plan for flexibility, reconfiguration, and manageability. Then recall that there are three laws or golden rules of networking economics and performance. And I stated that first, price performance of chips doubles every 18 months, according to the Moore law. Second, that value of networks is squared in proportion to the number of terminals attached, according to Robert Metcalfe from 3Com. And third, which is very important, you should always plan ahead for higher speeds. Also recall that the structured cabling system supports both voice as well as data, and also many include video, audio, security, fire alarm, and other applications. Also note that a LAN structured cabling system can encompass multiple contiguous buildings, such as a campus, and that TIA-EIA standards treat a campus just like a single commercial building with multiple floors on it. Also recall from Module 1 that these days of higher network speeds, the relative cost of cabling per Ethernet copper port versus the network electronics is substantially less, generally less than 10%. The golden rule here is that quality counts, so never scrimp on cabling, material, or installation costs. Always install the best network cabling system available because compared with the active electronics, the cost is insignificant, yet cable causes 70% of the network problems. Also note that I said previously that an ideal structured network cabling system must address the following design criteria: that it meets all regulatory codes such as local and national fire safety codes, that it follows TIA-EIA standards, it exhibits flexibility in its design to allow integration of a wide variety of voice and data components, that it also exhibits modularity in its design, which allows active component equipment to be moved and repatched without recabling, and finally, an ideal structured network cabling system allows for future upgrades. And finally, recall that according to industry sources, 70% of all network failures occur due to infrastructure problems, and 70% of all network service calls are cable related. Technicians spend 80% of service calls searching for network problems and 20% fixing them. And finally, most of the network troubleshooting time is determining end-to-end conductivity. So as I said earlier in Module 1, the answer to all these golden rules are telecommunications industry standards, which are the key to designing, installing, and certified testing a network cabling system. I'll talk more about the standards in the next module, but for now, let's review the standards approved physical media or cabling. The TIA-EIA standards call for the following minimum performance from unshielded twisted pair, called UTP, and other copper cable which has an impedance of 100 ohms, such as Category 3 using only voice applications and with frequencies up to 16 megahertz. Category 5E can be used for voice and data applications up to 100 megahertz, and Category 6, voice and data applications up to 250 megahertz. Note that you must use Cat6 cabling if you have a a gigabit network that is to the desktop. And also note that you need 10 gig in the backbone, which then requires optical fiber. Although approved by TIA-EIA standards, neither STP nor screen TP is commonly used in new networks today because Ethernet calls for unshielded twisted pair. And anyway, STP is an older IBM network cable, and screen twisted pair is a hybrid between UTP and screen TP. However, take a moment to review the differences in shielding and numbers of wire pairs between the two cables, because you still will run into these older copper cables. As I said earlier, certification performance testing of Cat5e and Cat6 copper UTP cable involves sophisticated cable testing instruments to perform the following tests. First, the wire map to check connections, then length, attenuation, near-end crosstalk, propagation delay, delay skew, equal level far-end crosstalk, power sum equal level far-end crosstalk, return loss, and attenuation to crosstalk ratio. I'll be discussing copper cable performance much more in a later module, but for now let me introduce you to three of the more important measurement parameters. First, attenuation, also called loss or insertion loss, which is the weakening of a signal as it travels down the cable. For example, the signal transmitted from the computer's NIC, network interface card, starts out at 4 volts, but ends up at the switch port at 1 volt. So the attenuation, which again is the loss of signal strength, is 3 volts or 75% loss, or commonly called 6 dB. Next important measurement is near-end crosstalk, or called next. Next is a measurement of noise coupling from the transmitted wire pair into the receiving wire pair detected at the transmitted wire pair end. Finally, attenuation to crosstalk ratio, or ACR, also known as headroom, is the difference between attenuation and near-end crosstalk. ACR is the best measurement of cable performance in copper cabling systems. Recall from Module 1, optical fiber cable has a huge number of benefits compared to copper. First, note that 2 strands of fiber, one for transmission and one for receiving, typically carry 20,000 two-way voice conversations in the long-haul PSTN network. That is equivalent of about 50 400-pair copper cabling. I think this is truly amazing. Other features of fiber compared to copper include long-distance signal transmission, large bandwidth, lightweight and small diameter, non-conductivity, security, and fiber is designed for future application needs. 2 varieties of optical fiber cable are commonly used in both LANs and WANs today. These are single mode and multi-mode. The mode can be thought of as bundles of light rays entering the fiber. These light rays enter at certain angles in multimode fiber because the light pulses are generated by an LED or light-emitting diode type power source. When single-mode optical fiber, which is a fabricated laser, transmits a single coherent light pulse. And like measuring copper cable performance, attenuation or loss of signal strength is a key measurement in optical cable performance. I'll be discussing fiber optics much more in a later module. This slide shows an optical loss test set, or OLTS, which basically is used to measure optical fiber performance. And it measures the amount of loss or attenuation in a fiber optic span consisting of fiber joined by connectors and splices under test, or the difference in power level of the signal measured at the transmitting and receiving ends in decibels. Coaxial cable is a well-designed cable often used for video applications because it can handle a huge range of frequencies. The standards call for using RG6 quad shield coax that has an impedance of 75 ohms in video applications. Coax cable consists of central steel copper flash core surrounded by a foam insulator, a braided metal foil braiding pair, and an outer plastic core called a sheath. Quad shield cable has 2 pair of foil braiding. The copper core carries the signal, and the foil braiding acts as both a shield against noise and a ground for the signal. The insulator layer protects the copper core from the metal shielding. The sheath protects the cable from physical damage. F connectors are used for coax cable. In the Hollywood movie Towering Inferno and in a real fire in Las Vegas Hilton during the 80s, fire spread from floor to floor using the building cables. Hopefully this will not happen again since everyone is using fire-rated cables. Again, we hope. There are important specifications that you must know if you are responsible for defining, designing, and installing a network cabling system. Basically, if inter-floor penetrations are properly fire-stopped, the cables will burn, but the fire will not pass the fire stopping, and that the toxic smoke from the burning cable jacketing will not be reduced, allowing people to exit the premise. Study the area of the building, identify as plenum spaces, then review the fire ratings, which are plenum, CMP for copper, and OFNP for fiber is the most stringent rating and used in HVAC, heating, ventilation, air conditioning, plenum areas, and they can also be used on lesser rating requirements. Riser, or CMR for copper, and OFNR for fiber. When placed vertically in a building, riser shaft going floor to floor, cable must not transmit flame between floors. General purpose may not be used to penetrate floors or ceilings, only used with a single floor. Residential is simply a single floor residential use only, and fiber and coax jacket follow the same rating as copper but use different markings on their jackets. Note that patch panels are generally used to terminate the horizontal cabling in data applications. They are mounted in a 19-inch equipment rack and have RJ45 style jacks on the front for the patch cords and 110 punch-down type connectors on the back to connect the horizontal cable. Also note that in addition to the 4-pair UTP found in voice and data horizontal cabling subsystems, multiple pair Cat3 voice cable is often located in the backbone cabling subsystem of the cabling plant. These voice circuits are terminated on either 110 or 66 punch-down blocks that are also used for cross connections. The binding colors white, red, black, yellow, and violet identify each 5 pair within the 25 pair of wire. The blue, orange, green, brown, and slate identified each wire pair within the 5 pair. The tip simply means the plus leg of the telephone circuit, and the ring is the minus or the ground. Each wire pair can be one telephone number. The concept of the binding color code can be extended to identify 25 pair groupings and can be identified within 50, 100, or 400 or so on pair cabling. This slide shows a voice application with a 66 block in the backbone. Also, regarding cable design, please recall from Module 1 that the following are the maximum cable lengths depending on whether they are used in the entrance facility, equipment room, telecommunication room of the work areas. The distance limits mandated by the standards include in the backbone for copper cable in the backbone that use data applications, it's 90 meters or 295 feet, and voice applications, it's 800 meters. When using optical fiber in the backbone, you have to consider whether it's multimode or single mode, where multimode is the maximum length is 2,000 meters, and in single mode it's 3,000 meters. In the horizontal cabling, the link, and that's used both for these limits are for both copper and fiber, the link is 90 meters or 295 feet, and the channel is 100 meters. Again, it makes no difference whether you're using fiber or copper in the horizontal link, or channel, the maximum distances are the same. In this overview of telecommunications cabling, Module 3, we discussed the golden rules of telecommunications cabling, including, first, that networks never get smaller. Plan for more users, more traffic, more capacity. Then networks never get slower. Plan for higher speeds, increased throughput. And third, networks never stay the same. Plan for flexibility, reconfiguration, and manageability. Then we discussed the different types of copper cable, including unshielded twisted pair, screen twisted pair, and shielded twisted pair. We also identified optical fiber, coax cable, and plenum cable design. And finally, we discussed the basic construction and performance of copper and optical fiber cable. This completes Module 3. Please take Exam 3, and I'll see you in Module 4.